Hello everyone, so here we are for the virtual instruction covering quarter 2, week 1 to 2, points to remember of grade 10 mathematics. Specifically, in this virtual instruction, we will be illustrating polynomial functions. If you have any concerns or queries after watching this virtual instruction, you may get in touch with your mathematics teacher so that he or she can assist you with whatever concerns you may have. To start off, let us define polynomial functions. A polynomial function of degree n is defined by the equation p of x is equal to a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 and so on to plus a sub 1 times x plus a sub 0, where n is a non-negative integer and a sub n is not equal to 0. Now, let us consider the numbers associated with our variable x. Here, a sub n minus 1, a sub n minus 2, to a sub 1, and a sub 0. These are what we call the coefficients of the polynomial function. Now, let us consider the exponents of the variable in each term. We have for the first term, we have your exponent n. For the second term, we have n minus 1. For the third term, we have n minus 2 and so on to 1, since this variable x here has an exponent of 1. And for the last term, it is being considered that the variable x here has an exponent of this y. It has only the a sub 0 and no variable x. By observing that n minus 1, n minus 2 up to 0 is the pattern of the exponents regarding the general form of a polynomial function, we can now assume that n is the highest exponent. By this, we can now say that n is the degree of the polynomial function. Now, let us consider some parts of the polynomial function. The term containing the variable with the highest exponent is called the leading term. From this leading term, we will be determining the leading coefficient, which is the a sub n. And the other part that we can identify is the last term, or what we call the constant term, considering that this is the term which does not contain a variable x. Next, we are going to name functions according to their degree. If a polynomial function has degree 1, then it is called a linear function. And its general form is p of x is equal to ax plus b. And then for a polynomial function with degree 2, it is called a quadratic function. And its general form is p of x is equal to ax squared plus bx plus c. For a polynomial function with degree 3, its name is cubic function, and its general form is p of x is equal to ax cubed plus bx squared plus cx plus d. On the other hand, if a polynomial function has degree 4, it is called a quadratic function. Its general form is p of x is equal to ax raised to 4 plus bx cubed plus cx squared plus dx plus e. If it has a degree 5, it is called a quintic function. Its general form is p of x is equal to ax raised to 5 plus bx raised to 4 plus cx cubed plus dx squared plus ex plus f. Now, it is called a sextic function if its degree is equal to 6, and its general form is p of x is equal to ax raised to 6 plus bx raised to 5 plus cx raised to 4 plus dx cubed plus ex squared plus fx plus g. And lastly, the ones that we have a name for, we have the septic function. It has degree 7 and its general form is p of x is equal to ax raised to 7 plus bx raised to 6 plus cx raised to 5 plus dx raised to 4 plus ex cubed plus fx squared plus gx plus h. How about if we have a polynomial function whose degree is greater than 7? How should we name it? The ruling for this would be the nth degree function. Okay, so if we have a polynomial function whose degree is greater than 7, we will now call it the nth degree function. So for example, we have a polynomial function with degree 10. We will call it 10th degree function, and its general form would consist the p of x is equal to a x raised to 10 plus b x raised to 9 plus c x raised to 8 and so on up to the constant term which is k. How can we say that a function is a polynomial function or not? Let us have these characteristics of a polynomial function wherein there are 4 and all of those 4 should be met so that a function would be considered as a polynomial function. Let us have the first. There should be no variables with negative exponent. So in these two examples, the first example, function of x is equal to 2x squared, passes the first characteristic. But the second example, function of x is equal to 2x raised to negative 1, failed to meet these characteristics. Thus, it would not be considered as a polynomial function. The second one, which is related to the first characteristic, there should be no variable in the denominator. So in this example, we have a negative exponent. Remember that in your laws of exponent, that we can have this negative exponent be positive if we are going to transfer it from the numerator to the denominator, and vice versa. If you have a negative exponent for the variable in the denominator, you can transfer it to the numerator. So this 2x raised to negative 1 is just equal to 2 over x, and which eliminates it from consideration in being a polynomial function for characteristic number 2. Okay? So let us have this another example. So we have the function of x is equal to 2 over x raised to negative 2. And we know that we can transfer this variable x to the numerator and we can have the 2x squared. Therefore, this function passes the second characteristic. And for the third characteristic, there should be no variables with fractional exponents. And for the first example, we have the function of x is equal to 2x raised to 1/2, wherein it has already a fractional exponent, which means it would not be considered to be a polynomial function. Next characteristic, we have there should be no variables enclosed in a radical sign. Take note of this first example. The function of x is equal to the square root of 2x squared. And then the second example, we have the function of x is equal to 2 square root of x. Let us still consider this second example. We know that we can express this as 2x raised to 1/2. This only shows that the third and fourth characteristic of polynomial functions are related, and at the same time, your first and second characteristic of polynomial functions are also related. That would be all for our quarter 2, week 1 to 2 points to remember for grade 10 mathematics. Thank you for watching and stay tuned for the next virtual instruction.